Okay, so today we're going to be talking about how you can solve a system of three linear equations using elimination. So you can use elimination to solve systems of three linear equations. I've got an example right here. And so we're going to start with this example. So begin looking for the variables with coefficients that are either the same or the additive inverses of each other. So when subtracted or added, these pairs will eliminate that variable. So I'm going to go ahead, this is going to be a long problem, so I want to go ahead and label these equations. So this is 1, 2, and 3. I'm going to try to keep that straightened out along as we go. So we want to look really at equations 1 and 3 first. So we're going to do 1 and 3. So we're going to say negative 2x plus y plus 3z equals 20. And then 3x minus 2y plus 3z equals negative 9. Okay, and what we're going to do with this is we're going to subtract these two equations. And when you subtract, you have to distribute this negative throughout. So it's going to be negative 5x. You're going to add, so you're going to have 3 plus 3y. And then you're going to subtract, which means that there's going to be plus 0z. And that's going to be a plus 9, which is 29. So now we've created this new equation. So this is going to be labeled equation number 4. So from there, we're going to, so you've eliminated the z variable through this. Now we're going to multiply 2 by negative 3 and add it to the first equation to eliminate the same variable. So we're going to be looking at 1 and 2. So 1 and 2, so we've got negative 2x plus y plus 3z equals 20. And we've got negative 3x plus 2y plus z equals 21. Okay, and so we're going to multiply this by negative 3. So you're going to distribute this throughout, and this will be your new equation. So you're still going to have this first equation the same, negative 2x plus y plus 3z equals 20. But this new equation is going to be 9x minus 6y minus 3z equals negative 63. Okay, so we're going to have a new equation. So we're going to have negative 7x minus 5y plus 0 equals negative 43. So this is going to be our fifth equation. So now we have five equations. We're going to first take 4 and 5, and we have two linear equations, so we're going to compare those. So 4 and 5. So our fourth one is negative 5x plus 3y equals 29. And then we've got 7x minus 5y equals negative 43. Okay, so we need to use the process of elimination for this one. So we're going to multiply this one by 5 and multiply this one by 3. And we're going to get a new equation again. So we're going to have negative 25x plus 15y equals 145. And then 21x minus 15y equals negative 29. So from here you're going to be able to eliminate the y variable. So we have negative 4x plus 0 equals 16. So you now have negative 4x equals 16. And then you have x equals negative 4. Okay, so now we've figured out what the x variable is. So from here, you're going to take, you can plug this back in, but I would suggest plugging it into one of the, your equation number 4. That way you can figure out what y is. So you're going to take equation number 4, and you're going to plug in, which is negative 5x plus 3y equals 29. You're going to say negative 5 times negative 4 plus 3y equals 29. Okay, and then you're going to just solve. So you've got 20 plus 3y equals 29. Then you have 3y equals 9, and then y equals 3. So you now have x equals negative 4, y equals 3. So then you can just plug it into, like I would do equation number 2. You can plug it into either one of these up here. But you've got negative 3 times your negative 4 plus 2 times 3 plus z equals 21. Then you're just solving. So you've got 12 plus 6 plus z equals 21. So from here you have 18 plus z equals 21, and then z equals 3. Okay, now we have all 3 of our solutions. So you would write this as negative 4, 3, 3. That's your x, y, and z. Okay, I hope this helps, and we'll be doing more of this tomorrow.